work by internal combustion, a process that happens in each of the engine cylinders. Air and a drop of gasoline enter the cylinder. The piston moves upward, compressing the mixture. The spark plug ignites the gasoline, causing an explosion that drives the piston downward, powering the engine. Engine components are housed in what's called the engine block. It arrives at this plant partially made. Here they finish it off by machining the cylinder bores, the holes in which the pistons move up and down. The tool carves a crisscross pattern on the cylinder bore walls. Lubricating oil will cling to the grooves in this pattern, enabling the pistons to move smoothly. After machining, the engine block travels upside down to the engine assembly line. When it arrives there, a scanner records the block's traceability code, a barcode that enables the factory to track the block through every stage of production. As the engine block travels down the line, error-proofing devices ensure that each component is installed properly. Elsewhere in the factory, meanwhile, the crankshaft is slowly taking shape. The crankshaft is a bar that's rotated by the up and down motion of the pistons. As it turns, it transfers power to the transmission. The crankshaft starts out as a roughly shaped steel forging. Robotic arms pass it down the line from station to station until, 20 tooling machines later, it's fully formed. They install a steel disc with teeth called the reluctor ring. They heat it and press it onto the crankshaft. As it cools, it shrinks to a tight fit. This ring helps time the combustion cycle. As it spins, its teeth pass in front of a sensor which reads the crankshaft's position and tells the engine to fire the spark plugs at precisely the right moment. Now they balance the crankshaft. If it's off kilter, the engine will vibrate. A computer analyzes the spin and determines whether they need to drill out metal at certain points to achieve equilibrium. Back on the engine assembly line, the engine blocks are still upside down. A robot lubricates the 4 bearings on which the crankshaft will turn. Then it drops the crankshaft into position. The pistons come next, 6 per engine, because these are 6-cylinder engines. The pistons are made of aluminum. Robots install them into the cylinder bores of the engine block. A steel connecting rod attaches each piston to the crankshaft. Now workers can close up the back of the engine block. A robot applies sealant to the rear cover. They bolt it on manually with a tool called a multi-spindle torque gun. On another line, they assemble the 2 heads that'll cover the top of the engine block. This robot is applying sealant to spark plug tubes before inserting them into the heads. The heads cap off the cylinder bores. They provide each cylinder with a spark plug and 4 valves, 2 for allowing the fuel mixture in and 2 for releasing the exhaust. The black tubes running front to back are the camshafts, the components that open and close those valves. There are 4 per engine. A robot applies sealant and then bolts a cover onto the front of the engine block, the head, and a component called the timing chain. This chain connects the crankshaft to the camshafts so that they rotate in unison. This ensures the valves open when the pistons are in the right position. Finally, they spin the engine mechanically to make sure the components function properly.
For safety reasons, aircraft engines have built-in redundancy features, like dual spark plugs and dual ignition systems. so that vital components have a backup. Rising gas prices and eco-awareness are compelling manufacturers to build aircraft engines that are more efficient and less polluting. Aircraft engines are remarkable pieces of engineering. To build a 4-cylinder engine, a worker wraps abrasive tape around what's called a bearing journal on a crankshaft. Using a polishing jack, he polishes the journal to the correct diameter, which he verifies with a digital snap gauge. An operator then oils the journal and attaches a connecting rod. These link the pistons to the crankshaft, which turns to generate power. Then he applies gasket sealant on the edge of the crankcase and silk thread that acts like a gasket, so when the two halves of the crankcase are joined, the engine won't leak oil. He places a camshaft into one side of the crankcase and measures the clearance to make sure it's a tight fit. Then he oils it to ensure there's no friction. They place the crankshaft and rod assembly into the crankcase, then join the two halves together. To prevent the connecting rods from hitting the sides of the housing, they put on what are called torque plates. He adds a little sealant to hold a gasket in place, then attaches an accessory housing, which holds all the gears and hoses that are mounted on the back of the engine. He installs the sump that holds the oil supply, then attaches a piston to each connecting rod. Now, he mounts a cylinder onto a piston and connects the part to the engine. He'll mount and secure all 4 cylinders this way. He inserts hydraulic tappets and then shroud tubes. He attaches them to the cylinder using a retainer. He inserts a push rod into each tube and fits a rocker arm onto each rod, completing the cylinder and valve action assembly. He steam cleans the engine. Then he paints it with rust-proofing enamel paint. Next come the spark plugs, one on the top and one on the bottom of each cylinder. He grounds and then installs 2 magnetos. These devices generate the electricity for the spark plugs, which ignite the fuel in the cylinder. He attaches the spark plug wires from the magneto to the spark plugs, then verifies the engine timing. Next come the heat shields, the intake pipes, all the spark plug connections and drain tubes, and finally a fuel injector. An operator then attaches a testing propeller to the engine to keep it cool during testing. He runs the engine using controls like a pilot would use and certifies everything from engine speed and temperature to fuel pressure and airflow. Hours later, he checks the oil filter for signs of foreign material or contamination, and this engine passes the test. A worker then puts preservative oil into the cylinders. This special oil safeguards the engine en route to the customer, whether they be general aviation manufacturers or individual owners. Once installed in the airplane, and after the standard pre-flight checks are done, the 4-cylinder engine allows the pilot to take to the clear blue skies in total confidence.